Earth is currently facing many changes in its climate. Greenhouse gases have been increasing in our atmosphere, causing glaciers to melt, sea levels to rise, and changing weather patterns around the world. Carbon dioxide measurements have been taken in Hawaii on top of Mauna Loa volcano since 1958. Currently, carbon dioxide levels are at 383 parts per million, 70 parts per million greater than what they were in 1958. If we continue to burn fossil fuels at the same rate as we do today, carbon dioxide levels could reach 1,500 parts per million by the time we exhaust our fuel reserves. Then, it will take tens of thousands of years to return to pre-industrial levels. Carbon dioxide is a greenhouse gas, and as it increases, it gives our atmosphere a greater ability to trap the heat from the sun. Many factors contribute to the climate of a region, and different regions are expected to get warmer faster than others. But the warming atmosphere leads to consequences such as sea level rise and unpredictable weather patterns. Scientists predict that the state of Florida will experience more rainfall and more extreme weather events.
So the precipitation regime can be changed. For example, we have higher rainfall intensity for the extreme rainfall event, and also the frequency of the extreme rainfall event has been changed, particularly maybe increased. Also, the category of the hurricane or the severity of the hurricane also becomes more frequent and the magnitude increased. We incorporate the historic data or trend into the global or regional climate model to simulate or to predict the future potential climate change scenarios. That simulation heavily depends on the emission scenario we use. Basically, it's the CO2 concentration 20 years, 50 years, or 100 years later. So the uncertainty of the future climate or the trend more and more depends on the emission scenario with the increase of our projection horizon. For example, 100 years later, then that potential climate scenario depends on the emission scenario.
It's critically important that students learn as much as they can about climate change, because the people that it's going to impact the most are not people in their adulthood now, not the people that are in government or in power now. It's going to be the people who are in school now, and their children and their grandchildren. Anything that we know or learn now about climate change will only be scratching the surface compared to what students and young people will be finding out in the next 20 and 30 years and further on. There are two main sources for sea level rise. First, as water warms up, it takes up more space. So the warming air temperature warms up the water, and the water expands and takes up more space. A second equal source is the melting of glaciers from the Greenland ice sheet as well as from the poles. And that is actually adding water to the volume of the oceans. So we have both an expansion of existing water and adding new water. That's causing sea level to rise. One of the ways that we can tell sea level is rising, one of the easiest ways, is from looking at tide gauge data. They use those to help decide what the daily tides will be from one day to the next, but it also creates a long-term record in some places of what the sea level has been and what changes have happened.
By the end of this century, based on the sea level rise projection by many researchers, so it's most probably maybe 1.5 feet of the sea level rise, so that's going to affect like 10 to 15 million people in the state of Florida. So that's very serious problems we're going to face.
Even with a rise of just 1 foot of sea level, thousands of people in low-lying areas of Florida will be facing the issues that are a consequence of flooding and storm surges. Infrastructure is highly susceptible to damage from water, but cities can take proactive measures today to plan for the effects of sea level rise tomorrow.
Naturally, beaches are eroded away. They're eroded away through just wave action. You know, when you go to the beach and you put your towel down and you notice that 4 hours later, the average water line is maybe closer to you or farther away from you. And when sea level rises, then that tide can intrude further inland. And the same is true for the surface waves, the waves that the surfers like to ride. And when sea level rises, then those surface waves can move further inland, and they are what really erode away the coasts and the beaches. And of course, when we have extreme events, whether these are events that we call like nor'easters, when we have strong winds that are coming from the northeast and impacting the shoreline, or when we're in hurricane season and we have something like Hurricane Sandy, and it erodes very severely away at the coastline and at the beaches. One of the most damaging things to structures during a flood is when the waves break on the structure. It really doesn't take much of a wave in order to knock down a concrete structure. In fact, just a 3-foot tall wave breaking on a 10-foot block structure can actually knock the wall down, because water has a tremendous force. So if we can get the waves to lose their energy before they get to the coast with constructed reefs, for example, that cause the waves to break out in the deeper waters, that can be useful.
The rainfall intensity becomes higher, so then that means discharge from the land also increased. So that like the intensified the rainfall and the storm surge and the higher water level in the ocean. So these three extreme conditions, when they come together, that's going to make the flood event or the damage so very serious.
We need to think about our roadway systems and whether the roads are elevated high enough. If they get overtopped, then simply you're not able to use that as an evacuation route because you can't drive down a flooded road. But when that happens, then oftentimes there's a lot of erosion of the road bed, and so you lose the support of the roadway. And if you look along the coast of New Jersey and New York, you'll see a lot of houses that are being put up on stilts. And that's one of the easiest ways. If you put them up on stable stilts, then the flood can simply go underneath them. You can have bridge pier scour where bridges are collapsing. In 2004, we had Hurricane Ivan, and Hurricane Ivan impacted the Pensacola region, and it actually destroyed one way of the I-10 bridge going over Pensacola Bay. And what happened is the storm surge raised the water level up high enough that the waves were able to knock the road deck off of the bridge piers.
By planning for sea level rise now, we can prevent a lot of the risks associated with infrastructure damage, including the loss of millions of homes and saltwater intrusion of freshwater drinking supplies. But the risk to Florida's wildlife is even greater. Many face the loss of suitable habitats, and the possibility of the extinction of many plants and animals in Florida is great. The biggest threat to coastal species is the heavily developed land on our coastline, because let's face it, people want to live near the beach. The movement of people inland could potentially cause an increase in habitat fragmentation and a rise in development, which threatens the ability of plants and animals to adapt to a changing environment.
And we know this has happened many times in the past because there's species in Florida, including near the present coast, that have ancient histories that go back millions of years. And so they must have been able to move as sea level rose and fell in Florida, because sea level has, been as much as 120 meters or so lower than it is today, but it's also been on the order of 6 to 8 meters or more higher than it is today. For some plants and animals that are relatively sedentary, they can't move very readily, they can easily be inundated, their entire known habitat, by rapid sea level rise, and they may not be able to move quickly enough to escape the rising sea. So it's a fairly simple problem.
There is modeling that exists that shows some of the habitat shifts that could happen as sea level rises. More water in an ecosystem, more salt water in an ecosystem, may change it to a whole different kind of ecosystem. In some places, it's expected that coastal forests will eventually turn into marshes. In an area where you lose aquatic plants, you might lose the benefits of those plants slowing down wave action. So erosion could become worse. Both commercial and recreational fisheries could become impacted when mangrove ecosystems or salt marsh ecosystems change. So we're already seeing changes to the oyster fisheries near Apalachicola in northern Florida because of a number of effects that could be caused by climate change.
Florida produces over 30% of the oysters that are consumed in the United States of America. In fact, in the Apalachicola region, 90% of the oysters are produced of all of those that are harvested in the state of Florida. Apalachicola is a very strong oyster habitat, but in the last year, the oyster harvest in Apalachicola was down dramatically. In fact, a lot of people that normally serve oysters in their restaurants are importing them from Texas. So we really don't understand exactly why that was, but some think that it is a function of sea level rise and of climate change because there was a drought and there's less water coming down the Apalachicola, so there's less fresh water, and the very salty ocean water was able to intrude into the oyster reef areas, and the oysters were not able to reproduce as well as they normally would. By the same token, that can cause a problem with our freshwater supplies when waters are moving in from the ocean and penetrating further inland, whether that's overland or whether that's underground, then they can cause contamination of our freshwater drinking supplies. For example, the Everglades, which is a large portion of the state of Florida, provides a water purification system. So water that slowly moves through the Everglades, a lot of it percolates downward and makes its way to the aquifer. And as it makes that travel through the vegetation of the Everglades and as it percolates downward, that water is treated naturally, it's purified. So when we extract the water from the drinking water wells, the water that we're getting from underground is very clean, and maybe all we have to do is to chlorinate it.
For other species that are able to move, that are more mobile, especially animals and plants that have very good dispersal capacities, say like they might have seeds that are dispersed by the wind or something like that, they're likely to be better off unless there are long or very wide stretches of land that is developed that they can't move across, especially for animals. You might have animals like, let's say, the Florida black bear or the Florida panther that can move for hundreds of miles, but if they're completely blocked by particular barriers like major highways or cities, they may not be able to move. And in the case of the panther, as an example, with just 1 meter of sea level rise, which is fairly modest, it's a fairly conservative projection, the panther would lose about 1/4 of its current habitat. And although the males have been known to disperse north and cross rivers and highways, no female has ever been known to cross some of the rivers that have been recently widened and channelized to accommodate boat traffic primarily. Nor has any female been known to cross major highways. And so the panther will basically lose about 25% of its habitat. With 2 meters of sea level rise, it'll lose more than half of its current habitat. And the panther, of course, is kind of emblematic of Florida, although it once was distributed throughout the southeastern U.S. So this will be a huge loss to Florida and to the nation to lose a species that is so unusual for eastern North America, where we have no large carnivores left. If there is no coastal development, so if we have wide swaths of land from the ocean to, say, the central ridge of the state that are undeveloped, many species will have good opportunities to basically shift their distributions landward as the sea rises. We know it sometimes in the past that entire coastal communities, by this I mean biological communities, like mangrove forests or salt marshes, have been completely removed from parts of the coast. We know that from geological evidence that shows that they just disappeared for some length of time. Then they gradually came back because they were probably found somewhere else and the species gradually dispersed back there. But if sea level rise is not so rapid and there's no development in the way, it's an entirely natural process and species will just kind of go back and forth as the sea level rises and falls and the coastline changes. One really amazing species, of course, is the Florida key deer, which is a dwarf deer, basically. It's a subspecies of the white-tailed deer that we find on the mainland, but it's about the size of a skinny Labrador retriever. So it's a little skinny deer. It's quite tame, but it's restricted now to a very small area of the coast. And it probably evolved only within the last 6,000 years or so ago, because only for that length of time have the Florida Keys been isolated from each other and from the mainland, because sea level has gradually risen since then. But now the Florida key deer would lose essentially all of its habitat, almost all, with just 1 meter of sea level rise. And so for a species like this, it's really a question of whether we just watch it go extinct in the wild or we bring it into captivity, because after a while there'll be absolutely nothing we can do for it in the wild. And so this is obviously something that a lot of people, I think, should be concerned about. Also, sea turtles, although we're unlikely to have any extinctions of entire species of sea turtles due to sea level rise in Florida and globally, because there'll always be some areas where they are able to adjust to the rising sea. In Florida, because of our very low topography, very low elevations, and a very rapid rate of sea level rise, and also the erosion that takes place due to increased storm surge from hurricanes and so on. Projections are basically that a lot of the beaches that are current nesting beaches have already lost a lot of their area for the last several decades and will be lost almost entirely. And for species like the loggerhead sea turtle in Florida, our population, especially in the area along the east central coast of Florida, the Atlantic coast of central Florida, we have the largest population of loggerheads in the entire Western Hemisphere. So to lose this population or have a huge diminishment of the population, which is almost certain, will be a tragedy. You can't just look at the impacts of sea level rise on species. You have to consider that in addition to what they're facing from, say, urbanization or from exotic species invasions and so on. And this includes considerations of how specific they are to a particular habitat. Okay, it also obviously it is dependent on where that habitat is. If it's a very low elevation area, so say that their entire known habitat will be lost with just a half a meter or a meter of sea level rise, obviously that makes them vulnerable. As I mentioned earlier, some species can move more quickly than others. So some species may be able to disperse away from the coast into suitable habitat further inland if it exists, whereas other species are so sedentary, unable to move, that they'll be lost with sea level rise. And of course then, as we mentioned, there'll be some species where development or other barriers will block their migration, so even if they have the inherent capabilities of moving, they'll be unable to because of human infrastructure, cities and so on that we put in the way. So we have to consider all those things, and also, the conservation significance of species.
There's so much benefit we get from ecosystem services here in Florida. We get benefit with recreational interests, whether it's people that like to simply go out boating, or maybe they like to go out kayaking, like to go out in a john boat and go fishing, or they like to go off the coast and do deep sea fishing. So there's a lot of recreational fishing that is an activity that Florida is very famous for. So there are oysters and shrimp and scallops and all these wonderful seafoods that we enjoy. Grouper and a red snapper and many different kinds of fish that are commercially fished. And these all can be endangered by sea level rise because their habitat, whether it's the submerged aquatic vegetation, the seagrasses, that can be impacted and lost, and then the fish don't have a place for nurseries.
We can't treat all species as equal in conservation. Some species are very distinct in terms of their evolutionary history. They have no close relatives, so they represent, a lot more evolutionary information than other species that have many close relatives. And some species play more important roles in their ecosystems than others. They may be what we call a keystone species, where if we lose them, many other species that depend on them will also be lost. Of those species that are vulnerable to sea level rise, we have a fairly limited range of options of things we can do. Again, if they're in an area that is likely to be entirely lost to sea level rise, like much of the Florida Keys or the Southern Everglades, if they're restricted to those areas and nowhere else, the only thing we can do, if they're unable to move by themselves, is either to physically move them to appropriate habitat, which has its risks because then they may have impacts on the species in that new area, or we take them into captivity. Otherwise, again, as we discussed, some species will be in a position where they're able to follow natural corridors and migrate inland, and so we won't maybe have to do much except for just stop further development from encroaching in those areas. Unfortunately, we're still having a lot of coastal development in Florida. We're still having new condominiums and hotels built right on the beach, which just is amazing because it's not a good investment economically and it's disastrous ecologically. So the first thing to do is to stop developing in coastal areas. So it all goes together, really responding adaptively for human communities and responding in an adaptive way to help nature survive have to be done hand in hand. They can't be done separately.
With the first approach to eliminating the impact of flooding is to retreat. We're going to be living more inland areas, so that can really be impactful to the local economy. If we don't have beaches maintained along the coasts of Florida, then an economic cost can be lost of tourism. If we have sea level rise and we have impact to fisheries, to commercial areas, to recreational areas, then we can lose boating and fishing from a recreational and commercial point of view.
Some countries that have had to deal with, that are very low-lying and have had to deal with sea level issues for a long time, like the Netherlands, are taking very intensive engineering approaches. In Florida, our options are a little more limited. For one, we have a lot more biological diversity than many temperate areas. And so we stand to lose a lot more in terms of species and natural communities than someplace like the Netherlands. Also, some of these so-called coastal armoring techniques, like building dikes and seawalls, really just put the problem off elsewhere. If you put up a dike or a seawall to protect one stretch of coastline, that energy is deflected and erosion actually increases and flooding will increase on another stretch of coastline. Also, those seawalls will prevent the natural movement of species and ultimately communities landward. And finally, they're not even going to work across much of Florida because our bedrock is so porous that the sea will come right underneath those seawalls and dikes. And in fact, storm surges in places like Miami, a lot of it comes not over the ground, overland, but it comes vertically right up from out of the ground. And so seawalls just won't work.
There are many places in the Florida Keys that are already experiencing high tides that are higher than they used to be. For example, there's a little restaurant right underneath one of the bridges in the Key Largo area, and pretty much every day at high tide, they have water up into their open air bar. Of course, it wasn't like that when they built it. They wouldn't have built it that way to begin with. But in different communities, including cities like Miami, high tides are regularly starting to reach over seawalls and into urban areas and onto places where people are living and working and playing.
The problem we face in a heavily developed state like Florida is that we have a very large human population, about 20 million, and a lot of it is located on the coasts. There's roads, there's private lands that we know with sugarcane fields, for example. There's obviously some cities and so on that will have to either be moved or at least adapted, put houses on stilts and whatever to make it easier. So a lot of the decisions we made in terms of where to locate development in the past in Florida, like really anywhere in the world, is assume that the environment doesn't change. It's static, that everything's always going to be the way it is today. But with sea level rise and climate change in general, we know that that's not the case. Well, one thing we can do today to help mitigate the effects of past activities is to help, that is for scientists and the more informed planners, to help counties, municipalities, state government, federal government, and all learn about what the options are in terms of adaptation. Learn that it is possible to have managed retreat, where we actually abandon or relocate human structures near the coast and move them inland. It's going to be expensive, but we're going to lose them anyway, so there's really little choice. We're going to watch them go at some future date, or we start planning for it, and again, identify those trigger points proactively so that we can start making decisions and taking action before it's an absolute disaster. In terms of conservation, it's the same thing. A lot of our conservation areas are on those few undeveloped stretches of coastline, and they're not going to be suitable. They're going to be underwater, or they're going to be a very different type of community. What was a coastal forest might become a salt marsh or a tidal flat. And so we're going to have to recognize we're going to have to start expanding the boundaries or moving the boundaries of those areas landward so that species can adjust to the rising sea. And this will take, again, some proactive planning. We can't wait until it's the last minute and things are going underwater rapidly before we take action.
Some people are extremely skeptical, particularly about whether or not human activities have caused any kind of climate change or sea level rise. Some people question whether it's even really occurring. Then on the other end of the scale, you have people who have a lot of faith in the scientific process. They understand the data. They understand that there's some uncertainty in the data and that we're always learning new things. And it's interesting to talk to some of the people who have lived in a coastal community for a long time or for numerous generations. They often have noticed changes that are occurring and are not surprised at all when you start to talk to them about sea level rise. They've seen it happening. They understand.
The simplest solution is to retreat. That is, just to move away from the coast. Of course, that's not something that most of us want to do. So we want to continue living along the coast. An infrastructure solution might be building a roadway that is elevated high enough that it serves as a levee protecting the inland area. We may build a seawall. A gray solution is trying to work within the constraints of the environment, using benefits of the environment in order to protect the inland areas from flooding. These can be enhancing marsh productivity. These can be in beach dunes, beach nourishment. These can be living shorelines where we put oyster reefs in, where we try to enhance natural habitats and natural barriers to flood that we know from our past experience diminish the impact of flood. Another is in the design of multi-story hotels or in homes where you have a bottom floor that's a breakaway floor. So you don't put anything that's of great value on the bottom floor, and the walls will actually wash out so the flood can just flow right through the understory of the structure. You know, I think it's really an interesting time to be getting into science and engineering, technology and mathematics, because we have an opportunity to not only understand the problems that we're going to face in the future that are associated with sea level rise, that are associated with climate change, but we can actually affect change.
The battle between the sea and our coast lies on the shoulders of the next generation of forward-thinking scientists and engineers. Unlike many natural disasters, such as earthquakes and tornadoes, we have decades of planning ahead of us before disaster strikes. This gives people hope that although sea level rise seems like an insurmountable obstacle for human and natural communities alike, we can take action now to ensure that when the time comes, we will be able to adapt to a new environment without our lifestyles being compromised, and while maintaining the rich biodiversity in Florida, which gives us so much, including food, recreation, ecosystem services, tourism, and a beautiful place to call home.